Okay, so let's talk about orbital hybridization here. So this is where we have those s and p orbital electrons that are the valence electrons. When they are shared in covalent bonds, it's not actually the shape of the s orbital or the shape of the p orbital. It's actually this hybrid s and p orbital. And we have to know how to name these hybridizations based on how many shared electrons we have and how many lone pairs we have. So let's take a look at how orbital hybridization happens for a second. So something like carbon, which has 4 available bonding sites, if we look at carbon's electron configuration with the 1s, 2s, and the 3 different 2p orbitals here, we know carbon's electron configuration is 1s2, 2s2, 2p2. And forgive me for not drawing completely straight arrows. What this looks like is that we've got 2 electrons without a buddy, so carbon should be able to make only 2 bonds in this case. Well, we know that's not exactly true. Carbon can make 4 bonds. So what actually happens is this electron right here is actually going to jump over to this 2p orbital. Okay, so if that happens, look, we've got rid of this one right here. And now we have how many spots available for bonding? 1, 2, 3, 4. So we've kind of changed the shape here, jumped an electron around so that we can create this hybridized s and p orbital. Okay, so in this case, we've used the s and 3 of the p's. Okay, now I'm going to show you exactly what this looks like here in an example. So that's what an orbital hybridized looks like. So let's look at something like CH4. All right, so we know from Vesper shape drawing that this is what CH4 looks like. It's a tetrahedral structure. So let's say we are looking at what is the hybridization of the C in the middle. Okay, so we're always going to look at the central atom hybridization here, and if there is ever more than one central atom, we'll tell you to pick one or do the hybridization for both. All we have to do is count how many bonded pairs and lone pairs we have. In this case, we have 1, 2, 3, 4 bonded pairs here. So we know that that carbon must be using the S and 3 of the P's for a total of 4 total bonded or lone pairs. So you see 1s plus 3 p's equals 4. All right. So we call the carbon of CH4 an sp3 hybridization. Okay. So let's look at another one here. So what about something like, we've seen this one before, BH3. We know boron has 3 valence electrons and is going to make a trigonal planar shape here with those 3 H's. So what we have to look at is go, okay, what's the hybridization of that boron in the middle? Well, let's count how many bonded and lone pairs are attached there. 1, 2, 3. Okay, so if there's only 3, then that must mean he's using the S, which is 1, and we got 2 left, so he's using 2 of those p orbitals, right? So he's got a total of 3. You always start with S, and then you add however many p's you need here. All right. Now comes the question of, what about double bonds? What about something like CO2? Well, we know CO2 is carbon double bonded to an oxygen on either side. So let's look. Let's look at the hybridization of that carbon right there. Here is the big key. So single, double, and triple bonds, they all count as 1. Okay, so let's look here. There's a double bond here. Okay, that's 1. Another double bond here. That's 2. We don't count those each bond individually in this case, so the double bond counts as 1, just like a single bond does. And there's no lone pairs on that carbon, so we call this hybridization 1 from S and 1 from P. So just SP. All right. So now you've seen an sp3, an sp2, an sp. Let's look at something that actually has lone pairs. Last one here. So let's say we're talking about NH3. Okay, we know that it has a trigonal pyramidal geometry, all right? And we've got the lone pair right here. Let's look at this guy right here. How many bonded and lone pairs does it have? Well, bonded pairs, bonded pair, bonded pair, lone pair. The lone pair counts, okay? Make sure to count those lone pairs that are sitting on that central atom that you're trying to find the hybridization of. So, if there's 4 total, then we know it's 1 from S, and how many? That's right, 3 from P. So we actually call this an sp3 hybridization. All right, there's a chart in your cheat sheet about how many bonded and lone pairs and you're looking for and what shapes make certain hybridizations. But hopefully this video helped you out in figuring it out a little bit.